So, today we are going to discuss about a very important topic from medicinal chemistry unit 4. Okay, it is chemistry, medicinal chemistry part. If you see the syllabus, okay, so unit 4 is medicinal chemistry, chemistry of the specific drugs it was given. So, within that today we will see the chemistry of cardiac glycosides. Okay. So, in this session I am going to discuss about what are the uses, mechanism of action of cardiac glycosides, different examples, very important aspect, chemistry of cardiac glycosides, classification of glycosides, very important, chemical tests of cardiac glycosides and profile of individual drugs. Let us see, this session will give you a very complete picture of cardiac glycosides. Okay. So, first let us see the uses, bullet points. It is used for congestive heart failure. So, cardiac glycoside drugs are used for the treatment of congestive heart failure. Next, slow down the heart in the arterial arrhythmias condition, particularly atrial fibrillation. So, fibrillation. So, cardiac glycosides are used for the treatment of arterial fibrillation, and it is apart from, so name itself indicates cardiac glycosides used for something cardiac related. Okay. So, apart from that, cardiac glycosides are also having other uses which we have to mention. So, like some of the drugs are used as emetics, diuretics and heart tonics. This already we have seen. So, apart from heart tonics, emetics and diuretics, see, one of the important point here is cardiac glycosides are having advantages as well as disadvantages also. So, most of the cardiac glycosides are having toxicity problems also, and this cardiac glycosides in the earlier ages they used as arrow poisons. Okay. So, poisonous nature is there for this cardiac glycosides. So, it is a dose dependent. So, used as arrow poisons, emetics, diuretics and cardiotonics. So, what is the mechanism of action? Mechanism of action, single point, it affects the availability of calcium to the heart muscle. Okay. So, it affects the availability of calcium for myocardial contraction and increases the sensitivity of myocardial contractile proteins. That is the mechanism of action. And if you see the drugs, digitalis, squil, strophanthus. Okay. These are the examples. Now, we will move into the very important aspect, chemical test for cardiac glycosides. Let us make this session something interactive. Whatever doubts you are having, please post. Okay. So, chemical test for cardiac glycosides. There are, how do you identify the cardiac glycosides? See, you will get bits like matching also. So, cardiac glycosides, whatever the chemical tests are there, the name will be given, and other alkaloidal tests. So, names of all these tests are important. So, when coming to this cardiac glycosides, there are 4 important tests: Keller-Killiani test, okay, Keller-Killiani test, legal test, Baljet test and 3,5-dinitrobenzoic acid test. These 4 tests are used for the testing of this or identification of the presence of cardiac glycosides. So, now let us see the overall gist of all these tests. Okay. So, I am not going to describe or give you the process of all the tests, what you are adding after this, after that, not required. You just remember the reagents. So, in what reagent is used in what test and what is the result, that is enough. So, Keller-Killiani test, lead acetate solution chloroform is commonly used. Okay. So, lead acetate solution, chloroform, glacial acetic acid, iron chloride, concentrated H2SO4. So, Keller-Killiani test, a reddish brown layer is formed which turns blue green after standing due to the presence of digitoxose. So, digitoxose is a cardiac glycoside, okay, and due to the presence of this cardiac glycoside digitoxose, the red color layer is turning into blue after standing for some time. Okay. So, this is the result for Keller-Killiani test. Okay. So, color change you have to remember, and you have to remember the whatever the solutions you are adding, like lead acetate solution, chloroform also. Here legal test also, lead acetate chloroform is common. Okay. So, one important point you have to remember is you are adding here sodium nitroprusside and 2 ml of pyridine in legal test. Okay. So, there is a chance of asking the test and the reagents also. Okay. So, legal test you will add pyridine and sodium nitroprusside. Sodium nitroprusside, very very important. So, see legal test and also you will add NaOH. The use of this NaOH is to make the solution alkaline. Okay. So, 𝗪-Killian's test, iron solution, iron chloride solution, FeCl3 solution. Legal test, pyridine, sodium nitroprusside. And what is the color change? You will get a pink color due to the presence of glycosides or 𝗪glycone moiety. I will tell you what is a glycone moiety, 𝗪glycone moiety. Okay, due to the presence of this glycosides, you will get pink color, red color in 𝗪-Killiani, okay, red color, pink color, legal test. Next, Baljet test. Baljet test, sodium picrate solution is used. The reagent used is sodium picrate and the color changes yellow to orange color in presence of 𝗪glycones and glycosides. Okay. So, here Baljet test color change is yellow, legal test pink, 𝗪-Killiani is red. Next, last test 3,5-dinitrobenzoic acid test. All these 4 tests are used for the identification of cardiac glycosides. Okay. And here you will use, the name itself indicates dinitrobenzoic acid is used, 3,5 dinitrobenzoic acid, that is 2% you will use, and NaOH. Okay. And the change is pink color. Okay. 𝗪-Killiani test is very very important, sodium nitroprusside in the legal test is important, picrate solution in Baljet test. Okay. This is the overall test. Now, let us move into the next one. Okay. Cardiac glycoside chemistry. Cardiac glycosides, so they will containing sugar part which is called glycone part, non-sugar part that is called aglycone part. Okay. So, this non-sugar part is the steroidal part in the cardiac glycoside. So, this cardiac glycoside is a combination of sugar plus non-sugar or glycone plus aglycone. Glycone is sugar, aglycone is steroid. So, these two will come when the glycoside is undergoing the reaction hydrolysis. On hydrolysis, sugar part is separated, non-sugar part is separated. Sugar part consists of sugars like these. So, it depending upon the drug, like digitalis is having some sugars, squill is having some sugars. So, depends upon. So, the overall examples of sugars, rhamnose, glucose, digitoxose, digitallose, diginose, sarmentose, valorose, fructose. So, you can remember all the O's are the glycone part or sugar part. One important point is almost all the sugars exist in beta conformation only. Okay, this is also the important point. The conformation, so which of the following statements are true? In that point, there is a chance of asking the conformation of sugars in the cardiac glycosides. It is beta conformation. And one more point is presence of acetyl groups on the sugar affects the lipophilic character. So, acetyl groups always imparts the lipophilicity to the molecule. So, wherever the acetyl groups are there on the sugar part, they impart the lipophilic part nature, lipophilic character to the sugar molecule. Then non-sugar part, coming to the non-sugar part. So, this is the picture of digitalis. Okay. There will be a OH at 3rd position, okay, and another OH at 14th position. So, the steroidal part consists of 2 OH groups. How many OH groups? 2 OH groups. One is at 3rd position, one is at 14th position. Okay. 3rd position OH sugar is linked. Okay. So, I am just not drawing the structure, sorry. Yeah. 3rd position sugar linkage, through 3rd OH sugar linkage, and 14th OH is unsubstituted one. Okay. 14th OH is unsubstituted OH. Substituted OH is 3rd OH which is linked to sugar. glycon. Next 17th position lactone will be there. At 17, C17 lactone will be there. Sugar attachment is at 3rd OH group, that is what I said. 14th OH is unsubstituted, and this lactone is there, right, because depending upon the source of that glycoside, whether it is plant source or animal source. So, depending upon that source, the lactone position is same C14, but the lactone number changes. For example, if the glycoside is from plant source, then 5-membered unsaturated lactone is present. 5-membered unsaturated lactone. I will show you the picture. Animal source, 6-membered unsaturated lactone will be present. Okay. So, each and every point is a bit here. Okay. Beta conformation of sugars, sugar part is called glycone, non-sugar part is aglycone. Non-sugar part consists of 2 OH groups, one OH is linked to sugar at 3rd position, another OH is unsubstituted one at 14th position, lactone is present at 17th position. 17th position lactone, depending upon the plant source, animal source, the number divides, changes. Let us see how it is changing. One more important point, sugar non-sugar part will get divided by means of hydrolysis reaction. Now see here, classification, okay, what I said, depend this C17, it is 3rd, sugar linkage will be there, okay. So, leave it, and C17 substitution will be there, okay. The lactone ring is 5-membered unsaturated, 6-membered unsaturated, okay. 6-membered unsaturated, then it is from animal source, and that is called bufadienolide, bufadienolide. 5-membered unsaturated, that is called butyrolactone ring. This is butyrolactone ring which is unsaturated, which is 5-membered. This is called cardinolide. So, cardinolide consists of which of the following? So, which of the following is true about cardinolide? Unsaturated lactone, saturated lactone, 6-membered unsaturated lactone, 5-membered unsaturated lactone, something this combination can be given. So, remember cardinolide, 5-membered unsaturated butyrolactone which is from plant source. Bufadienolide, 6-membered unsaturated lactone, this is from animal source, and this ring is butyrolactone and this ring is pyrrone ring. Pyrrone ring is seen in bufadienolides and butyrolactone ring is seen in cardinolides. Example, and now one more important thing is how many carbon steroid? Cardinolides are C23. See, this is 5, this is 6, 1 carbon extra, that is why this C24. Bufadienolides consist of how many carbons? 24, C24. This is cardinolides, C23. You see the examples here. So, what I said, cardinolides are from plant sources, 𝗪𝗵𝗶𝗁, cruciferae, 𝗪𝗿𝗡𝗃, all these are cardinolides from plant sources. Bufadienolides are examples Liliaceae, Ranunculaceae. I will just correct this one, okay. Bufadienolides are having the animal source also. Okay, 6-membered unsaturated lactones. Okay, Liliaceae, Ranunculaceae are other examples which are having C24 ring. Okay. Next, we will see the individual drugs. Yeah. So, I said now we will see the individual drug profiles, okay. So, examples of this cardiac glycosides. Digitalis, first example is digitalis, synonym is purple foxglove or lady's foxglove, belonging to the family Scrophulariaceae, okay. And source is dried leaves of digitalis purpurea, and if you see, digitalis is having chemical constituents cardiac glycosides, two kinds, primary glycosides there, purpurea glycoside A and B, and it is also having glucogitaloxin. Other cardiac glycosides includes odoroside H, gitaloxin, verodoxin, glucoverodoxin. You have to remember all this. and particularly you have to remember the purpura glycosides. What are the primary glycosides? Purpura glycoside A and B and glucogutaloxin. These three are primary glycosides: purpura glycoside A, purpura glycoside B, glucogutaloxin. Others are oderoside, gutaloxin, viridoxin, glucoviridoxin. Okay. These are used for the common things, okay, like cardiac glycosides, internal hemorrhage treatment, inflammation, delirium, epilepsy, acute mania. Okay, these are the uses for digitalis. Now, digitalis another species. Digitalis purpurea is this one, which is lady's glove or purple foxglove. Digitalis lanata. Okay, Digitalis lanata is also the same family, but it is called Grecian foxglove. Okay, what is the difference between Digitalis purpurea and Digitalis lanata? The chemical constituents are differing. Chemical constituents, if you see, purpura glycosides A and B are present in Digitalis purpurea. Digitalis lanata, lanatosides A, B, C, E. Okay. Lanatosides A and B are acetyl derivatives of purpura glycosides, which is a very important here. Which of the following lanatosides are the derivatives of purpura glycosides? See, lanatoside A, lanatoside B are the acetyl derivatives. Which derivatives? Acetyl derivatives. Acetyl derivatives of what? Purpura glycoside A and B. Purpura glycoside A and B, if you perform acetylation, then it converts into lanatoside A and lanatoside B. Okay. So, acetyl group addition. And the treatment used for the auricular fibrillation and congestive heart failure. Okay. Important points are the, remember the chemical constituents here. Next, see very important slide, the metabolic conversions or the conversions of this glycosides, how they are converting. So, this purpura glycoside A undergoes enzymatic hydrolysis in presence of digipyridase enzyme. So, purpura glycoside B, A and B in presence of enzyme digipyridase converts into digitoxin plus glucose. Okay. First is enzymatic hydrolysis, purpura glycoside A gives digitoxin plus sugar molecule, okay, like a glycon and glycon. So, a glycon here is digitoxin, glycon is glucose. Again undergoes hydrolysis and gives digitoxygenin plus how many molecules of sugar molecules? 3 digitoxos. So, digitoxin, digitoxygenin, these two are aglycon hydrolysis products of purpura glycoside A. Okay. And again here also digitoxos. So, purpura glycoside B hydrolysis products are gitoxin, gitoxygenin. Okay. I is added, that is it. Digitoxin, gitoxin, digitoxygenin, gitoxygenin. Okay. So, A hydrolysis products are glucose 3 digitoxos. So, this is the same, sugar molecule is same. Second hydrolysis you will get digitoxos, 3 molecules. Okay. So, digitoxin, digitoxygenin are from A, gitoxin, gitoxygenin are from B. These are the sugar molecule, glycon part hydrolysis products. And if you see, this is a structure not required. See here the sugar, I have said the third position, sugar is attached to this through OH at third position, and another OH at 14th is unsubstituted. Okay. And C17 is the substitution of this another lactone ring. Okay. So, this is digitoxygenin and digitoxos. One important point here is digitoxos and digitalos. Digitoxos sugar and digitalos are desoxy sugars found only in cardiac glycosides. Okay. So, these are found only in cardiac glycosides, digitoxos and digitalos. Okay. Next, one important another point, lanatoside C, lanatoside A and B are the acetyl derivatives of purpura glycosides A and B. And one more is there, lenetoside C. On hydrolysis it gives you digoxin. Lenetoside C gives you digoxin. Viridoxin, which is also the the cardiac glycoside of this one, digitalis purpurea. On hydrolysis gives gitaloxygenin and digitalos. So what you have to do, so many hydrolysis products are coming, so you have to make a table. Hydrolysis products, glycone part, aglycone part. How many glycone part molecules? Aglycone, what is the molecule aglycone part? What is the enzyme? What is the substrate? That you have to make a table, that I did for you, that I will explain you here. Next, first we will complete all the individual drugs. Okay, so now digitalis is one source of cardiac glycoside. Another source is 𝗪𝗿𝗃ia, also called as lucky nut tree. 𝗪𝗿𝗃ia or lucky nut tree. Next, it belongs to the family Apocynaceae family, and source is dried seeds. Here you have observed this, please observe the source. Digitalis are dried leaves, 𝗪𝗿𝗃ia is dried seeds, squill is dried bulbs, okay, dried scaly bulbs, dried bulbs of squill, okay. So 𝗪𝗿𝗃ia, dried seeds, also called as lucky nut tree, belonging to the family Apocynaceae. Digitalis belonging to the family Scrophulariaceae. Okay, what are the chemical constants? 𝗪𝗿 A, 𝗪𝗿 B. This is B is cerebroside. Perivoside, nerifolin, thevenin. Thevenin is ruvoside. Peruvosidic acid, which is perucitin. Okay, these are cardiac glycosides, and sugar units, 𝗪𝗿ose, D-glucose. You can remember the sugar units easily. O's will be there and glucose, okay, you can identify as a sugar. 𝗪𝗿ose is the sugar part, and aglycone parts, 𝗪𝗿 A, 𝗪𝗿 B. Which of the following cardiac glycoside is a cerebroside? 𝗪𝗿 B. Perivoside, nerifolin, thevenin, rivoside, perivosidic acid and perucitin. Okay. So these are the important chemical constituents of this 𝗪𝗿𝗃ia. Okay. You see the uses here. Uses are something peculiar. Okay. From roots, the drug from the roots is used for tumor treatment. Roots are applied over the tumors. Okay. So it is used for tumor treatment. And seeds are used for abortifacient, purgative action, rheumatism. Okay. Rheumatism, abortifacient and purgative action. This is about 𝗪𝗿𝗃ia. Now squill. Squill synonym is Scilla bulb. Okay. Scilla bulb, this is European squill. Why I am stressing here is Indian squill is also there. So European squill and Indian squill are different and belonging to the family Liliaceae. Okay. And source is dried bulbs of Argynia maritima. Dried bulbs of Argynia maritima. And only example which is having which is containing this bufadienolites. Okay, bufadienolites are also seen in frogs. Okay, that's why animal source it is said like that, because it is not that bufadienolites are present exclusively in the animals, but bufadienolites consists of one carbon extra C24 and it is containing 6-membered pyrrone ring. Okay, the source is the animal as well as the plants, and here Liliaceae family squills consists of bufadienolites. Okay, and other animal sources are frogs also. Okay, bufadienolites, silarin A, silarin B, silarin A, silarin B. So to one important point here, if you see, silarin A is an active constituent. Okay, silarin A is the active drug containing constituent. Silarin B is in the amorphous form. Silarin B is amorphous form, and there will be an enzyme silatinase. Okay, and here see bufadienolites and cardinolites both are present in this squill. Bufadienolide is silarin A and silarin B, and cardinolide is glucosilarin A, glucosilarin A. And common stimulating action, expectorant, diuretic, cardiotonic, asthma. Okay. Only the thing is here roots, seeds, the source is different. And one important point is squill shows negative results with biologic test and legal test. So, common chemical tests are 𝗪𝗪𝗃 test, biologic test, legal test to the dinitrobenzoic acid test, but especially the squill will show negative with legal and biologic test. Okay. Generally we will expect to be positive, but it will show the negative results. The 𝗪𝗵𝗶𝗃𝗃 test is positive in squill glycosides. So, which test is used for the identification of squill glycosides? 𝗪𝗵𝗶𝗃𝗃 test. Okay. So, which of the following cardiac glycoside will give negative result for legal test? So, we will all the other digitalists and will give you the positive test for 𝗪𝗪𝗃 legal biologic test. So, squill will give you the negative result. So, which of the cardiac glycoside is tested by means of 𝗪𝗵𝗶𝗃𝗃 test specially, that is squill. Next, Indian squill. Indian squill is also called as 𝗪𝗵𝗶𝗃𝗃 sea onion 𝗪𝗵𝗶𝗃𝗃, okay, and belongs to the family Liliaceae, and say dried bulbs of Argynia indica. European squill is Maritima, Indian squill is Argynia indica. Species is different, genus is same, and chemical constituents same like squill, silarin A, silarin B, bifidobacterides. Example uses also cardiotonic, expectorant, stimulant, catalytic, diuretic, anti-cancer. Okay, it is almost same like Indian squill is same like European squill, but the different, somewhat different. Okay, uses are also same, but the source is different. Next is 𝗪𝗵𝗶𝗃𝗃 seeds, Strophanthus. Strophanthus consists of cardiac glycosides, synonym is 𝗪𝗵𝗶𝗃𝗃 seeds belonging to the family Apocynaceae. Okay, dried ripe seeds of Strophanthus 𝗪𝗵𝗶𝗃𝗃. So, here also the seeds, source is seeds only. Okay. And you see here K-strophanthin, it is a mixture of 3 glycosides. So, the chemical constituent in Strophanthus is K-strophanthin. Okay. K-strophanthin is a mixture of 3 glycosides, cymarin K, strophanthin P, and K-strophantoside. So, these 3 are the important K-strophanthin consists of these 3, cymarin K, strophanthin P, K-strophantoside. Okay. Sugar unit is cymarose. Okay. So, you see one important point here, methoxydigitoxose is called as cymarose. Methoxydigitoxose is called as cymarose. Okay. Then diuretic action improves circulation in case of heart weakness. Okay. This is all about the individual profiles. One more drug is there, that is oleander. Oleander, Apocynaceae family, dried seeds and leaves of Nerium indicum, and chemical constituents are oleandrin, gitoxygenin, neridignoside, okay, neridigenoside, and adainergenin. Okay, oleandrin, gitoxygenin. Okay, these are the chemical constituents of oleander, and root is applied externally in hemorrhoids and ulcerations. Okay, root is applied externally in the hemorrhoids and ulcerations. This is about the individual overall idea about the cardiac glycoside sources, examples. Okay, now only important point is this slide. Okay. So, what is a cardiac glycoside component? Hydrolysis products. Okay, sugar component, glycon part, aglycon part. First you see purpura glycoside. Purpura glycoside undergoes hydrolysis and gives digitoxin plus glucose. Digitoxin again undergoes hydrolysis to give digitoxygenin plus 3 digitoxose. Next, purpura glycoside B gives gitoxin plus glucose. Gitoxin undergoes again hydrolysis to give gitoxygenin plus 3 digitoxose. Sugar part is same in purpura glycoside A and B. Okay. Next, viridoxine gives ketaloxygenin plus digitallose. Okay. Viridoxine gives which of the following cardiac glycoside consists of the sugar molecule digitallose. That means in its structure digitallose is present, viridoxine. In purpura glycoside, purpura glycoside A glucose, and digitoxin it is digitoxose. Lenotoside C consists of digoxin. Okay, everything is unique. See, digitallose is for viridoxine, digoxin is for lenotoside C, digitoxose is for digitoxin. Okay. Next, glucosylcerin A, 3 glucose molecules plus 2 molecules of okay. So, rhamnose, 1 molecule of rhamnose, 3 molecules of glucose, okay, and silyrenin. Okay. 3 glucose molecules, rhamnose, and 1 molecule of silyrenin, it is glucosylcerin A. Next, again the silyrin A. Silyrin A gives prosilyaridin A plus glucose. Silyrin A is prosilyaridin A plus glucose. Prosilyaridin A gives aglycone silyrenin A and sugar is rhamnose. Okay, prosilyaridin A, aglycone part is silyrenin A and rhamnose. Silyrin A, again silyrin A which is specifically acid hydrolysis. Okay, silyrin A is giving prosilyaridin A. If it is undergoing acid hydrolysis, then it is gives sillabiose. Okay, sugar molecule changes. Okay, silyrenin A plus sillabiose. Sillabiose is nothing but glucose and rhamnose. K-strophanthin gives strophantidin, aglycone strophantidin. Okay, so you have to remember viridoxine, digitoxin, okay, and lenotoside C. Acid hydrolysis of silyrin gives you sillabiose. Okay, sillabiose composition, glucose and rhamnose. Okay, and strophanthin, strophantidin you can identify. So, remember this part is very important, especially digitalis glycosides hydrolysis product, sugar product and non-sugar product also very important. So, in the next class we will see the another concept in the same unit 4. Okay. So, whatever the doubts you have you can ask, okay, and okay. So, this is the important part. The next part we can see again. Thank you. All the best.